There we go. Perfect. So I am here to talk about, very loudly, I'm here to talk about the Zabbix Database. We've been using Zabbix, as I mentioned yesterday, for about 5 or 6 years, so long before the API. In fact, I don't even know what the API can do, so I apologize if some of this already is covered in the API. But we actually do a lot of SQL integration reports and things from the database. So I thought an interesting talk for some of you would be just a little bit about the database. We've spent years trying to understand it and understand where things are and some of the trickier pieces and parts. And actually, it's pretty good. That's about me. Get down to this. So the Zabbix Database, we're on 1.8, and there are a bunch of changes coming into 2.0 and 2.2. The only significant one really in the database for us is the loss of last clock and last value on the item table, which actually really sucks because it really screwed up a lot of our reports. And I'll talk about and show you some examples of that. But broadly, the database is really nice. It's got some weird things. It's got some weird naming. It's got some confusing parts, but it's pretty good. Everything is keyed. Everything's on IDs. Everything's very clear. The naming is pretty good once you understand things. Everything is status-driven once you understand the statuses. There are some overlapping things. There are a lot of key values. If you look in the source code in defines, you'll find all the values for all the statuses, all the types, all the everything that you can use in your SQL. So it's pretty nice. And I actually have a 2.2 diagram for those that want it out of MySQL. And we have a 2.0 diagram. We have a 1.8 diagram and a 2.2 that's annotated that you might want. It'd be nice if Zabbix guys publish that. But anyway, about 110 tables. As I said, all things are joined. All timestamps in Zabbix are in epoch time. So everything, Zabbix calls this the clock. So you'll see fields in all the tables called clock. That is epoch time. So that's seconds from 1970. So you get to love your Unix timestamp and from Unix time when you're writing SQL. So unfortunately, unlike a lot of other systems that doesn't use, of course, regular dates, this is really fast, really nice. You just have to convert it every time you want to use it, every time you want to test something. So you have to be careful. These are the key subsystems, as you know from your menus, of course. There's hosts, items, and all that. They all have tables, very conveniently. The core system that I want to talk about quickly are obviously hosts, templates, items, and so on. And then you can download this PowerPoint. I have pieces for all kinds of other things, all the audits, everything except macros, I think. So again, I'm trying to talk really fast. So key thing to understand is how the hosts, items, and templates work together if you're working in the database. It is not completely obvious, and so it's critical to understand this. Obviously hosts and items are the key part of the system, right? Hosts, of course, are the servers you're monitoring or devices. Items are the things you're monitoring. So it's very clear. Hosts have items, right? One item can only be associated with one host, linked by ID, very simple. There's some SQL here to look at that, very simple, what's the item, what's the key, what's the last clock and last value. So in 1.8, on the item table, I can get the last time this value was updated. This is the last time Zabbix saw this data and the last value. In 2.0, this was moved to the history table. So you can't have this SQL becomes several pages, unfortunately. But this is really nice for a lot of stuff that we do because we do a lot of analysis on the data. Not really the analysis you saw earlier today, trends and so on, but we do a lot of stuff looking for servers that are low on swap. We look at ratios, we look at status of things, we get versions because we run everything everywhere. So how many Nginx version 0.93 do I have? This is how I find that. How many systems don't have swap? Because Amazon, for example, doesn't have any swap by default. How many of those have we fixed? How many have we forgotten? This is how I find that. So we analyze this data for a lot of operational details, file systems, a lot of stuff. So templates. Templates are great. Templates are actually hosts. So in the database, templates are hosts of status 3. So this is where things are confusing. Status 0 hosts are active hosts. Status 1 hosts are disabled hosts. Status 3 hosts, what did I say, are templates. So it can be a little bit confusing as you start to join things around that statuses have multiple meanings. Sometimes they're enabled, sometimes they're disabled, sometimes they're an error, and sometimes they're totally different things like templates. So when you're trying to pull out items from templates, join to hosts, looking at data, you have to keep all this in mind. there's something called template ID, which you'll find on items and triggers. Template ID is not the ID of the template. Template ID is the ID of the item on the template that you're connected to. Sorry, I don't have a diagram for this. But essentially, if I'm an item on a host and I have a template ID, that ID is the corresponding item in the template that I came from, my parent, if you will. Does that make sense? So you have to work on this. So how do you find items that are on templates? They have template ID 0. But items that are on hosts without templates also have template ID 0. So you must join items to the host to figure out if it's a templated item or not. There's no other way to know. If I have a random item, I have to join to its host and see the host type to figure out if this is on a template. So I have lots of SQL to give people, and we'll put online somewhere that deals with all this. But as you're trying to look and find things, and again, in our world, we try to find things that are misconfigured. We try to find things that on templates are enabled, but the item's disabled. Or somebody's changed it here and there and so on. So this is really important to us. So working through the template item host world is interesting. Hosts have templates, of course. You attach a host to you attach a template to a host. But that's not all that happens. Probably a lot of people realize, but you may not. When you add a template to a host, the front end copies all of the items and all the graphs and all the everything from the template to the host. So if I have 10 hosts and a template with 10 items, I end up with 110 items in the system because it copies all 10 of the things from the template to all the hosts. So when you start looking at the data and items, this creates a huge explosion of things to deal with in SQL and so on. And so here's a nice little thing. It just shows me here, you can see this is the item agent version on the template. It has template ID 0. Its ID is this. But on agent version on these two hosts, WebDev and DNS, have a different item ID, but their template ID is this. And this is how you know how they're connected and where they come from. And notice also the host status is different. So this type of thing lets you navigate all of this. So another quick area is triggers, events, and functions. Most people, I think, use triggers on single hosts, but you don't have to, right? A trigger can have items or have logic that spans hosts. This complicates things because I can't connect a trigger directly to a host or an item. I have to use the function system. So all those little basically when you write a function or and, or, plus or minus, whatever, in a trigger, that creates items in the function table, which then links off to the items. And it's a double link table. Functions link to triggers and triggers link to functions, sort of. So this makes it really hard because you want to say, this trigger is based on what host? Or show me the triggers from the host. It creates quite complicated SQL because you have to link through the function system. So a lot of times you'll have a trigger, you'll have an event. I want to know what host that's from, or I want a list of hosts that caused low disk space yesterday. That's actually quite a bit harder than you'd think to get SQL-wise, so because it links through the function system. Here's some examples of that. So now that you get all the simple stuff, I'm going to run through some of the more table things quickly. I talked about hosts already. Proxies are also hosts. Again, host status 5. So proxies are really part of the Zabbix system. They're really not part of the hosts, but they're kind of in the same table. This is even more complicated because we monitor our proxies. So our proxies are in the host table twice, once as a monitored host and once as a proxy. So if you do things by name, this screws you up. It's a lot of fun. Can be disabled, enabled. There's an unreachable state that I don't really understand, and so on. You can list active hosts, very simple, where status equals 0. Different stuff, very easy. Items are, of course, all the fun. There's different types. We use mostly agent. You can have others. It's all pretty basic. And again, in 1.8, we get the last collection time. We get the last value. In 2x, you lose this. But this is really useful. We're thinking about doing a view or a function to do that. We already talked about this. Items are copied from the template. And I already have that graph you can see. Here's an example of where we're pulling some swap information on some servers on Amazon. We're looking at last values, sort of 88% versus 1% and so on. Very easy to do in 1.8, more painful in 2x. But we do a lot of this type of thing. We want to see this stuff. This is one page of the 5 pages it takes to do this in 2.0 because the history tables are by data type. So before, here, I could do it by last value, and MySQL will change the types for me. Here, in 2.0, I have to actually know the type value and some other issues, and I have to leap through all the right tables. This is a little painful. Quickly talk about the Zabbix queue. You've probably seen the Zabbix queue. You go to Administration Queue, and it shows you the queue. The nice thing is that this is not really a queue. There is actually no queue in Zabbix in the server. There are queues in the proxies. So you have to be careful because the proxies have two types of queues. The server only has one. So what a queue actually is the number of late items. So it's very simple. It takes now, and if that's greater than the last clock plus the interval, it's late. And in the page, you can see later than 10 seconds, later than 1 minute, 2 minutes, and so on. So the maximum number of items that can be on this list is equal to your number of items. So if you have 100,000 items, your queue can be 100,000. And we actually split this out, and we have SQL to pull this by proxy for graphs. The server can show it to you by proxy, but it can't graph it, and it can't trigger on it, which is really annoying. So we have custom SQL that goes and pulls this data. So we have nice graphs that show us where all the proxies are, how many values I'm getting per second from the proxy, and I can trigger on this. I can say who's late, who's not, and so on. But anyway, so that's how it works. So things can get stuck. Our queue still has a lot of stuff stuck in it. There are a bunch of cases, I don't really understand them, but where you disable the host, or it went into error, and then you turned it off, things get stuck in the queue. So for us, the queue has a lot of crud in it that we'd like to get rid of. And we have lots of good SQL, like I said, for that. Triggers, we already talked about this, link through functions, so just skip through that. Different values, URLs are here, very simple. Trigger dependencies, and I think this changed into 2.0, there was some database changes. If you want to track dependencies and so on, that of course is in the table. There's a trigger up, trigger down sort of system that seems overly complicated. So I think some of this was changed in 2x. Sorry, I'm going kind of fast. It's important to remember that the triggers are triggers, right? Triggers are a logic on a host on some values. The things you see on the dashboard are not triggers, they are events, right? So, and they have event IDs. And so if you want to work with them or integrate them to other systems, it's the event ID that you're picking up. Now this is great, except when the server restarts, it recreates all the events. Took us a while to figure out. And so when you've done like we have done and you've modified the database and added ticket numbers and so on, you lose all that. So we've had to hack the server to fix this. But be careful if you make things dependent on the events, because when the server restarts, essentially all the triggers are unknown and it reprocesses them. To you, looking at the dashboard, it looks exactly the same before and after the restart. But actually, those are all new events with all new IDs, and it copied the acknowledgements. So you can't really tell that this happened. So this will screw you up if you try to link in to different things. A lot of fun. So one of the things that's a challenge is I want to know yesterday the average event length. I want to know how long I had high CPU on this server. This actually is surprisingly difficult to get because it's not really stored. What you have to do is look at the time interval between an event of type problem and an event of type OK, based on when the trigger changed. And we do this across all of our data. This is the simplified SQL that does that. And this takes a long time to run across. Our event table has several million rows. Because there's just it doesn't store today how long that event happened. It just gives you this list. And so, I'm sorry, it's hard to read. I have a better version. But you have to, so there's multiple loops, there's multiple joins here, trying to figure out and scan forward, looking for the next OK item on the same trigger. So we find this very useful. It's a pain. Could be better. History and trends. I'm doing time-wise. History and trends. As you probably know, data is collected into the history tables of the different types, right? There's floating point, string, and so on. At the end of the trend interval, the history interval, that gets converted to trends by the server. So you have the trend table, which is the long-term table, and you can scan that and analyze it, as was talked about earlier. This is purged by the housekeeper, of course. Although I just discovered 15 minutes ago, looking at the source code, that the housekeeper only purges 4 times the housekeeper interval. And this is a big problem because we only purge once a day, and this now explains why I have too much history data. But anyway, web checks, I'm going to skip that. And I'm going to skip script. User and security, pretty simple. A little bit confusing because you have user groups and host groups. Don't get them confused. And some more SQL. And again, we'll put all this online and share this. Permissions are complicated. They're really nice, I said yesterday, but you have to remember that in complicated environments, users will only be able to see screens and graphs and these things if they have permission on every single item in there. And it is very easy to, and also will notify that way. It's very easy to create a screen that has a couple little points from a couple other systems. And if you have a low permission user and they're not in all the groups, they see nothing. And this can be really painful to debug. And so we gave up on this and had to go to a simplified system. But we have some SQL and so on that can help you show me all the hosts I have permissions on by walking all these tables. Because it's really frustrating when you get a graph and you try to figure out which of the 100 items on 50 graphs am I missing permissions on. Because it could be one extra survey you forgot to put in the group, and it's painful to see. So we have some stuff to think about that. Somewhat confusing, I think this has changed in 2x. If you have a lot of users, there's a lot of load on the system to refresh all these dashboards. And this is stored in lots of different places, and it's not documented as far as I know. There are a couple user refresh settings that are used when you add users, but that is only for the graphs. The front dashboard has a very complex set of things in the profile dashboard refresh rate, but this is not the only one. There are several others that are hard to set, and the default to like 30 seconds. These are the things you can click on in the corner, and it drops down and shows you. If you go look at those for new users, and you have hundreds of users like we do, you find everybody's refreshing every 10 seconds. Really a challenge. So we have SQL that goes through and just resets everybody continuously. But I wish it was better documented because I really don't know what they all are. But that's an issue as you scale up and do stuff. The audit log, as I mentioned yesterday, is not that great. The audit log is great. The UI is not. This is some SQL that sort of gets things out. What I'm interested in is, this trigger, resource ID 109482. Here in the status, somebody disabled this. I want to know who did that. This SQL will tell me the name of the user that did this and when. So that's extremely useful. You can't get this today out of the user interface, but this is really useful for us. And we're going to build some PHP pages that get this, show me what user did what, who added this trigger, who changed the status. It's great because it literally tracks who changed that field, who changed history from 3 to 4. All of that is in the database. You just got to get it out. So we have stuff for that. What does this do? Oh, this is when some hosts were added and some more stuff. And you see it's a little bit complicated to try to figure out some stuff. And so, as I mentioned yesterday, we have lots of reports that track lots of stuff. We have these updated for 2.2, things that are disabled, lots of different stuff that's missing URLs, all that. So this all comes out of the database. That's why we have a lot of experience. Housekeeper we talked about, backups we talked about yesterday, and that's it.
Thank you, Steve. Any questions?
Well, it's not even a question, it's more of a comment. I would really advise you to use the API for most of that stuff.
I would love to.
Yeah. So, starting from 2.0, it's pretty much fully documented. It's pretty stable. So, and most of this stuff that you talked about, the templates, the links between items, templates, it all is all implemented there. Also, you can get the last values and the last log from the items without having to query the history tables.
Yeah, the challenge for us, though, is I have to play with the API more, is I wanted to see it across the whole system. I want to find swap across everything and certain keys and mixes and matches. So I have to see how, it's usually not show me one item on one thing or show me the items on this one trigger, which generally are looking more broadly than that, but it'd be interesting to spend time with it. So
yeah. We have some options for filtering or like text search and stuff, so yeah, it should get me done.
So you don't need any of this then, don't worry.
Well, it's not as much question as the note. We're also extensively using access to the SQL table. Like, for example, we tie host information in the Zabbix to our DNS server. So basically, Zabbix serves as source of the name IP address. And if we're going to use API calls for that, it will not going to work because it's too slow.
That's a real concern. And we do the same thing, actually. We cross-reference this with our system of record every day to make sure to see where we're missing servers. And so we do big joins, and we cross-server join.
So my point is use of the SQL calls, and it's still pretty valid tools, and it's still going to be used in the future until API will be fast enough.
This seems to be a remark session. I wanted to let you know that you probably will be happy about 2.2. It does not recreate those events upon the server restart anymore, which should help a lot, at least in some cases.
Oh, good. That's good to know.
Thank you.